The final part 4 of lecture 1. Let's now here's the point where we start discussing about Python. And this is an overview. So it's kind of a, again, look at the overall view, summarized view about Python, an introductory thing. Actual Python related things, we will get started with the next lecture, right? Next session. Now this is now we are finishing this lecture number 1, which you should study as part of the next week's activities. But remember that there will be a lab number 1 that you have to do. Lab number 1 will have certain things you need to do with Python, as well as some examples of C language also. But we haven't started discussing Python in lectures, right? So you might be wondering why, but so we think it should still be okay because in the lab we need to do something from the beginning also. So we have given some simple enough task for you to do for lab number 1 in Python also, although we haven't yet discussed Python as we begin, right? By the time you do lab 1, we wouldn't have discussed that much of Python. But we hope that it's something that you can manage, be patient, and just follow the instructions in the labs and do the lab number 1 that way. But as you go on, you will basically start understanding things better. All right, so let's look at this Python overview. So Python has this particular symbol, right? Python is it's a reptile, it's an animal in the sense. So in the case of computing various computational tasks when it comes to computer languages, or sometimes with respect to various other tools and systems that people develop, it's very common to name things after animals of various kinds, right? So you would see various things named after animals. Because it's some people love animals, and they just want to give some names, and they may thought, okay, just let's give a name of an animal, right? So that's a common thing for people to do. So Python is a general purpose high level language. When you say general purpose, it means there are certain languages which have been specially designed or developed or invented for some specialized kind of work. Python has been aimed to be general purpose and fairly high levels. But of course, when you look at Python now, how it's being used, there are certain areas where Python is being heavily used. One being that when it comes to various kinds of research activities, for example, in various research domains, if you are not a very good programmer, perhaps if you are not really trained that much for programming, you might still be able to do a lot of various things using Python language. So that's just one example, right? Also, when it comes to text processing things, this includes research that I earlier described, and also a lot of AI related work. You have to deal with lots of data, and including data like natural language things and so forth. Python is being heavily used as well, right? And so many applications, I would say, actually. So the design philosophy of Python includes code readability. That means easy to understand code, right? Which is also means that this code being small amount of code also is basically part of that in a way, because for a particular task, the code that you produce can be small, which makes it easy to understand as well, right, in a sense, right? Because if it's a very long program, it might be somewhat challenging to understand. So it's this code readability along with this expressing concepts in a small amount of code. It's basically what results in small amount of code, right? So you can express a concept or even some action. You can complete some action using a small amount of code, right? Of course, while it is being general purpose high level, it can also be used in different kinds of programming, what we call programming paradigms. So paradigm is programming, let's say another word, maybe the programming styles. There are various different ways or different styles that people do this programming thing. Certain languages have been developed according to these paradigms. For example, object-oriented style of the paradigm is one such example. So there are languages like Java is example, C++, and so many others, which use object orientation as basically the approach, right? So we have basically collections of objects that interact with each other, and they basically write the code for them to complete certain computational tasks. There's also a paradigm called functional, where many things are seen as functions and special syntaxes and special way of performing the computations. And there's this called imperative languages, like you give a certain command like structure, where people refer to, for example, imperative is more or less like procedural as well. C language, Pascal, and so forth are examples. Right? And now Python can be used in any of these formats also. Can be used in object-oriented way. It supports object orientation. It has objects, basically object-oriented paradigm is part of that. It can be used in a functional way or imperative way. Maybe most common way that we use would be this called this imperative way, right? And some special features. It has some actually contrasting with C language. It has this dynamic typing. Dynamic typing means now again contrasting with C language or even with Java. So in those languages, you can't just arbitrarily use variables or data types. You have to first define if you want to declare some, if you want to use some data with some what we call variables. If you want to store some data, let's say they are integers or real numbers or whatever, you have to declare the variables before you use them. So that way the compiler will know what type of data you are referring to, you are going to use. That makes the compiler's life easier, and it allows compiler to make lots of optimizations, that is why the code becomes faster. But Python actually allows dynamic typing. It actually doesn't require you to specify the types of data that you are going to use. Anytime you can introduce new data, and at runtime, that's why we call it dynamic typing. At runtime, Python will figure out things and try to accommodate various kinds of data, various types of data. That's why internally it's quite complicated, right? So it's very nice features for programmers. Of course, things become quite easy, but the execution environment, it's quite complicated because of that, right? Also, now this dynamic typing is basically the lack of that in C and other languages, similar languages, makes it, also make its programs getting a little longer, and programming time will get increased, the code will get, and so forth, all these things, right? Another similar situation is this automatic memory management. Particularly in languages like C, if you want to get additional memory, the program will ask politely from the operating system and get that amount of data it wants. The programmer has to write code for that. Programmer will insert code to get request memory from operating system and use it in a certain way. And once its use is over, the program will return that memory back to the operating system. Right? The programmer will write code for that. So that's a very nice way of using memory, which is a scarce resource in a computer. So the C programs are usually like that. C programmers also are used to that. That means use memory and other resources sparingly. And it's basically, if you want, you basically request, right? So at runtime, it can happen. Of course, at the time of compilation in C programs, also you can do some memory allocation, but If you need huge amount of memory, you never do that. C programmers never demand lots of memory at the compile time. I mean, in what we call the static kind of allocation, it happens in a dynamic manner at the time of execution. So that leads to more efficient memory usage in such programs. But it is not there with respect to Python. Python has automatic memory management. That means we never, as programmers, as Python programmers, we never ask special memory from the operating system. Please allow me. I mean, there may be very special situations where you may need to manipulate certain things, but I mean, at least if you consider the programs that you will try, and even many other programming, very serious programs people do, you don't really have to worry about memory. You read, if you want to read a huge file, which is, let's say, 1 gigabyte in size on the disk. If you have enough memory in your system, you can simply just read it in a very short, by using a short amount of code. And you don't have to do lots of, memory management thing. If you have to read a long, huge file into the, if you have to go through in a C program, you would simply maybe allocate some amount of memory, we call it a buffer or some space for you to read the content. And maybe you keep reading it in a, segment by segment. Because that's how it can be done, because we have allocated a certain small amount of memory for that. And you would read segment by segment, portion by portion. So because it basically does its own memory management, whereas Python programs, automatic memory management. Simply what it means is users or the programmers will not have to worry about allocation memory. Whenever you need, it is there, as long as the underlying system has the memory that you want. Okay, so that's some basic properties. Python is an interpreted language. We basically said that this means Python code gets executed line by line. But I actually said, if you read the chapter 1 notes, there is a little bit of a slight difference, actually speaking, strictly speaking, but we can ignore that detail and just consider that it is an interpreted language, pure interpreted language, and code gets executed like line by line. Right? That's fine to go with that kind of assumption. You can use two main ways. There are two main ways to use or work with Python. That means when you consider in the beginning, as you learn to program, one is called the interactive mode, where you interact with the Python shell. So a Python shell is basically a kind of interface that you have with this Python system. And so what we do is you simply give a single Python line of code or a statement or expression, and it executed by the interpreter and displays the result. So Python shell will accept your input and it gives to the interpreter, which interprets, and that means it translate and execute, and the shell will then display the result. It's just one expression, one statement that you can give. So this Python shell is known as what it is, REPL. That means goes around a cycle: read, evaluate, print, loop. Right? So it reads what the user is typing, evaluates it, read the result, and continue. Right? Loop means continue the same thing over and over again. Now this has some useful things out of this. If you want to try some command, some special something, if you want to just try, you can simply go to the Python shell and try that command or the statement and see whether it works, how it works. You can try out various things. Very useful. You don't have to write, save your code in a file and execute, and you don't have to go through all those things. Very quick, very simple. You can try it on the Python shell in interactive mode to get an understanding how something works. Right, a particular command, a particular function, all these things, very easy using the interactive mode. Very useful also. The scripting or programming mode is the more common thing when it comes to how people use actual programmers, experienced programmers use. They may also use interactive mode to try out something, but generally speaking, here programming mode means you use some editor to create a .py source code file containing many lines of code, and then you basically, once you are done, you can execute. You can give that as input to the interpreter, which will execute the whole thing, but of course happens line by line, right? Some serious amount of computation, if you want to do, obviously you would go to the scripting mode or programming mode. Right? Okay. Now, in the case of when you want to in this semester's work, we basically in the very beginning to prepare your computer for CS1033, we said that install Python version 3.11. So idle is basically what we generally recommend. So we can download from the python.org website the latest version and get it installed on whatever the operating system that you have. The Windows version, you can see here the screenshot from running on the Windows machine, the Python 3.11.3, which I have installed on my computer. This is how it looks like, the Python shell. Now, this is when you install Python, idle means integrated development and learning environment idle. It comes with this Python shell also, which I show here. This is Python shell. It's actually, it has some initial messages that it displays, right? And this is one of the, under the options or somewhere we can get the help menu, and when you select the about thing, and it shows these things, right? Idle, integrate the learning environment and certain the details. All right. So, of course, some students, even in the first discussion, asked whether they can use other development environments. Of course, yes, you can if you want to. We don't prevent you from doing that. But we advise you, if you have not done any programming before, or you may have done a little bit of programming, but if you haven't used any integrated development environments, we suggest you start with idle, right? We recommend that you start with idle, which is fairly simple, easy to use, not that much sophisticated, you can say, yes, but it does the basic things that you need for the semester one work for CS1033. Idle is more than enough. Right? You can do quite a lot of things with idle. So it's more than enough for our work in semester one. But if you want to explore, yes, it's indeed a good thing to explore other development environments, like there's something called PyCharm and whatnot. There's maybe Visual Source VSC from Microsoft and so forth. There are various other tools and development environments which will support Python, right? So just even if you just start, if you're starting now and let's say you follow our recommendation and you start using idle, we are not saying you just limit yourself to idle. Even in that case, after you get familiarized, later you can of course try out other development environments. So it's a good thing to get familiarized with different environments, right? But anyway, this is what we recommend for you to get started, right? Yeah, so Python idle is a basic one, but it's perfect tool for beginners. It supports both interactive and scripting modes. Interactive, you can see here, this is the shell that normally it starts with the shell, but you can also, here you can see the file menu is there. Under that, you can start editing files also. So it provides both options, obviously. And here's a screenshot of how it is used in interactive mode. Right, you can say this three symbols like this. It's basically indicates the prompt, right? When you, for example, here right now, when you after getting the previous inputs response from it, your cursor will be blinking here, waiting for you to input a Python statement or expression, right? So that's what we basically have done in the very first, as the first thing is a print, and within parenthesis, hello world, those two words, and it is displayed here. And if you say 2 plus 4, it simply does evaluate that expression, and 6 is produced. 10.0 divided by 3, it's like a 10 divided by 3 as a kind of a real number. It keeps going 3, 3, 3, 3, 3. Interestingly, you can see it's basically rounded into 5 somehow. It's truncated, right? We know that 10 divided by 3 is a never-ending sequence of 3s, but here it's being displayed by truncating at some point, right? So this is basically interactive, but you can see whatever things that we type, and the response is in blue color here. And 2 plus 4 is V type, and 6 is the response we get from the shell coming from the interpreter, and it gets executed, and result is shown like that, right? So yeah, we show the Python shell with the idle. Enter Python code at the prompt. It's like these 3 greater than symbols indicate where the command we should enter. The point where the command, or not necessarily a command, maybe a statement, a Python expression or a statement to be entered, right? That is where you have to enter the Python code. And you can do also interactive mode in the terminal window, right? Here, of course, we saw that we are doing it in the idle shell, right? Python shell. But here, there's a we show how it may be done on in this case in a Windows computer. You get the command prompt, and in that, when you type Python, basically gives you this description. It's similar to the description in the previous thing. You can see like the message that looks similar, right? In this shell window, it gets opened with certain standard things. So similarly here, when you say Python, it gives this display this standard thing, and then gives these 3 greater than symbols, and that means expecting us to enter something. When you enter, it gives the response, and then you get the prompt again. Then you get another some input, provide another, and it is evaluated and it's displayed, and you get the prompt again. Like that, you keep going, right? So to start off here, you have to say Python, then you get this Python shell in that terminal window also, right? So if you want to have this Python shell without the idle, yeah, what you can do is open the command prompt that's within a window or a terminal, and type Python and press enter. And this will start the Python shell, right? Okay, and going further, right, we mentioned about this in the earlier session also, how using these Jupyter notebooks, how you can actually use some of the examples given in notes, how to get them executed without having to copy. And of course, you could have if you have some Python code examples in our notes, if you want to try them out, one option is, copy that code from that and in your notes and paste it into idle editor or something like that, right? And save as a file and execute. But Jupyter notebooks provide a nice alternative way to execute such codes without having to copy and paste into a idle or anything, right? Idle or something like that. Jupyter Notebooks is basically, we have provided, you can download from Moodle Jupyter Notebooks for various different chapters in the Python topics in our notes. What you will see things like this. If you open it, I think in order to be able to use Jupyter Notebooks, there are certain installations or setting up you have to do. So that's part of setting up your computer. So if you don't have Jupyter Notebooks, or if you don't know what it is, please follow instructions on Moodle and set that also on your computer. If you have difficulties, let us know. And once you have set up Jupyter Notebook on the computer, you can copy the Jupyter notebooks for various different chapters from our Moodle site, and then you start the Jupyter notebooks on your computer, and you can then point that Jupyter Notebooks to open one of those the Jupyter Notebook files that you would have downloaded from our Moodle, and it will open it and it will show it like this. So here I am showing you one thing. So we have chapter 4 control structures. So this is the Jupyter Notebook corresponding to that, and this one shows if you when you read our notes, you will realize that in various places we provide example code in the notes. So here's the program 4.1 occasion where you have program Python code is given here, right? And what you can see is that it's actually a small area where you can actually get that code executed. So you can see these menu items are there. So you can actually run. While you are inside this, you can make it run. So get it executed, and when it happens, the result, if you are supposed to, here you can see, this basically means you have to enter some input. So it's prompted here. So it's executed correctly. And if you enter 98 here, according to this one, you get this message. So this example shows how perfectly correct execution happens, and it will give the certain sensible data. It gives the expected results also, output, right? So simply the certain kind of interactive mode provided by Jupyter Notebooks. Why do we say that? When you execute it again and again, at every time you can give different inputs here for the marks, and depending on that, you can check whether it gives the correct output, right? So basically you can test. So you should try these things with the notebooks we created, we have provided. So it's basically notebooks, those Python notebooks have been created, Jupyter notebooks have been created from our Python notes, right? So this is an additional kind of way for you to see how programs get executed, right? How programs run. Small snippets of code, you will get this. Jupyter Notebook version will help you to try out. It's all right. Okay. So under scripting mode example, program 2.1, which is actually an example in the notes that we have provided. So you can type, you can even actually copy and paste from the notes into an idle editor. So it's a small amount of code, so you might as well just type it. And you can then go to this run option, and you will have to save with the name, right? And then run option will basically let you run the program. Okay. So scripting mode basically is what you mean the programming mode. You can do it with idle or any other suitable editor, right? Where you basically you type into a text file. So we say we edit the program and save it, save the code as a .py file. Right? And then we invoke the interpreter with the program file as input. The code that we have written, that program file is given as input to the interpreter. Right? We can invoke this interpreter. It's in command line, as we have mentioned earlier. Or within the idle kind of environment, you can simply do it with the mouse and other key shortcuts and so forth. And the other thing, good thing about scripting mode is that because the code we have typed is in a file, you can keep it saved on the disk for future use. In the future, if you want to use it again for something, or you want to make it a part of a bigger program, you will always have access to the saved file on disk. And if you want to, once you have it that way, you can modify, run, that means rerun, or repeat these things as many times as you want to get some work done, basically, right? Okay, so this is the scripting mode example. Here I'm showing the screenshot of this site that we talked about, the visualization thing. So you can basically go to the site and run this pythontutor.com site. Here, when you have the code, actually it supports the various kinds of Python versions. When I checked, I saw it's Python 3.6 they support. And you enter the code here, the line numbers show this automatically generated. And then you can actually go step by step. You can see here, say next, last, or whatever, it will allow you to execute things one by one and see on this side of the screen, it tells you various things that you display using print, or the values of different objects or variables and so forth are shown. So you can inspect how things happen at the time of execution, right? Values of variables and so forth can be observed on this side. So it's a nice way to see how the execution takes place and what happens to various objects that we have been using, right? What values they have and so forth. Sometimes it can be useful to even debug. You have a bug in a program which you find it quite difficult to understand why or the reason, find the reason. Maybe if you do things like that, perhaps you may be able to find it easier, right? All right. So this is basically a site for you to go and check, pythontutor.com visualize. And okay, that brings us to the final slide. So this is the end of our lecture number 1. Just to recap what we discussed, we looked at programs and program development, the step-by-step sequence we went through. And as a part of that, there were some important things we went on to a little bit detail. One is that about algorithms and algorithm related a few description there. And then about program translation, the compilation versus interpretation. Need a comparison of C versus Python, and some overview of C, just to give you an idea of what C language environment looks like, basically. But so overview of C was quite a short one, because we are going to, after that point onwards, it's simply a focusing on Python. So we briefly looked at Python and how it be used. So we will continue from there next time.